Hey everyone, welcome back to EduVibe. So today we will start with the another topic of 1D kinematics, which is acceleration. So we know that what is acceleration. So acceleration is also the vector, so that's why we write it as a like this, a vector. We put the arrow on a. So the acceleration is the rate of change of velocity. So when the rate and the change of velocity will happen, so we tell that this is the acceleration happening. That is how quickly the velocity changes. That's how quickly the velocity changes. As we saw there, like if we we have a greater velocity, so we have a greater acceleration on the same direction. So it depends. And if we have a slowing velocity, so it goes like opposite direction of acceleration, which is in negative direction. So the acceleration is equal to the delta v divided by t. So delta v is change in velocity. Delta v is change in velocity, and t is time, which is time taken. And if we write in change in velocity, so change in velocity is final velocity subtracted by the initial velocity upon time taken. So units for this is meter per second square. So why it's meter per second square? Because if like delta v is our in like velocity is in meter per second and time is in seconds, and we will do the multiplication, we get meter per second square from there. Acceleration is also depends on how, like if there is in positive and if the velocity will changing and is increasing or decreasing, positive, negative, or zero. So if acceleration is in positive, if like a is greater than 0, so we have increase in velocity. If we have acceleration in negative, like a is great less than 0, so we have velocity is decreasing. If we have acceleration is 0, neutral, or we can say that if our velocity, no change in velocity, anything, it remains in constant velocity. So we have to like know about this. Like another thing is that if the velocity and the acceleration are in the same direction, like we see in this, like the velocity and the acceleration goes on the same direction, so then we say that we're speeding up. Acceleration is speeding up, velocity and acceleration is speeding up on that way. But if it is in like opposite direction, velocity and acceleration in opposite direction, so it's slowing down. So we tell that if car is slow, that velocity and acceleration in the different directions, opposite directions. If car is speeding up, so with the velocity and acceleration in the same direction. So let's deal with the example for this using that formula which we do with the acceleration. So while braking, a car experiences a backward acceleration. So here our acceleration is on opposite direction and velocity is on the, like if the velocity is on the forward direction, our acceleration on the backward direction. And acceleration we have given 7.40 meter per second square for 2.8 seconds. At the end, it is a moving forward 31.5 kilometer per hour. What is the initial velocity? So firstly we have acceleration. So we write that acceleration is equal to 7.40 meter per second square. We have time to, which is 2.88 seconds. And at the end, like after the car stops, and that the final velocity is 31.5 kilometer per hour. So this is our final velocity. We have to convert this kilometer per hour into meter per second, because velocity is always, if we do it with the acceleration, is always be meter per second. So we have to do 31.5 into, we know that we have to multiply it by 1000 divided by 3600. When we multiply this, we get 8.75 meter per second. We get 8.75 meter per second, and we want to find out the initial velocity, so we have to find the vi. So here's the thing, that the acceleration is in the opposite direction. So if the velocity goes like in right direction, like the forward direction, so it's positive. But the acceleration is in backward direction, so backward direction we take as negative. So here our acceleration should be in negative. So why it should be negative, we have to know that it should, because it's in the backward direction. So now we know that our formula for us to find acceleration is the vector that we know that delta v, and we know that delta v is final velocity minus initial velocity. So we know the final velocity minus initial velocity divided by time taken. So we know that final velocity is 8.75 meters per second minus vi. Vi we have to find upon is 2.8 seconds. And we also know that acceleration, so we put acceleration of minus 7.40. We have to find that vi. To find that, we do like cross multiplication, we do like this goes with this and this goes with this. We get 8.75 meter per second minus vi is equal to minus 7.40 meter per second square. Always go with the units to get the exact unit what we want for the velocity or anything which we find. It's multiply by 2.88 seconds. So when we do this, we get 21.312. It should be in minus, and here we want for vi, so minus vi goes over there, and this that is positive, so here it goes with negative 8.75 meter per second. So for seconds I can cancel. So we do over there like minus minus is the plus, so we do addition and we get minus 30.062 meter per second. Here negative negative cancel out, and we get the like approx value of 30.1 meter per second, because we need a 3 set this like in this, but we start with kilometer per hour, so we also hand with the kilometer per hour. To get into the kilometer per hour, we do the same, like we do the opposite for this. We do kilometer per meter per second for 1000 upon 3600. We do 3600 upon 1000 to again goes to the, and we get vi of 108 kilometers per hour. So this is our initial velocity in kilometer per hour, because we start with kilometer per hour. So let's do another example to know about this topic more. Like we have now object experienced an acceleration. Again, we have acceleration of 4.50 meter per second squared towards the west for 8.10 minutes. And what was the object's change in velocity? So change in velocity, we know that we have to find delta v. So in that case, we didn't have to know about that final velocity and initial velocity, because we have to find the change in velocity. So firstly, we have again acceleration, which is 4.50 meter per second, and we have time, which is 8.10 minutes, but we need this in seconds. So we do 8.10 minutes into 1 minute is equal to 60 seconds. So minutes cancel, and we get the 8.10 multiplied by 60, we get 486 seconds. and we have to find the delta v. We know that acceleration is equal to delta v upon t, and we have to find this. So we isolate delta v to that acceleration times t. So we know the acceleration, which is 4.50, and the time is 486 seconds. This is in meter per second squared. So second one cancel. We get this like 2187 meter per second. And this should be negative. Why should be negative? Because we take that acceleration is in the west direction. So the object experiences that, and the change in velocity also goes in the west direction. And we know that our west direction is always the negative direction, and east should be in positive direction. This is our east and this is our west. So the west is a negative, so we take change in velocity in negative. And then we do, if you want, so you can convert the point, because we need the 3 seconds is the 4 seconds. So the point is over there, so point shifting like 1, 2 and 3. So shifted like that. So we get 10 raised to power 3 meter per second, and we get 2.19, which is in 3 seconds now, and we get delta v in minus. So this is our like delta v. So here's for this lesson, we are completing with the acceleration topic. In next video, we'll start with like graphical analysis with the acceleration, with the uniform acceleration. So we talk about in the next lesson, learning made simple with EduVibe. Learn smarter but not the harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.